Hello viewers, this is Wagda Ronald taking you through this tutorial for O-level mathematics. And this video we're going to talk about the topic of addition and subtraction of matrices. So this video will be suitable for students in senior 3 and senior 4. So matrices is the plural and matrix is the singular form. So a matrix is a rectangular arrangement of numbers written in the form as shown below. So our interest is this form. So if numbers are in that form, we shall call it a matrix. Now R1 represents the first row and R2 represents the second row. Then this C1 represents the first column and C2 represents the second column. What does that mean? It means that A lies on the first row and in the first column, while B lies in the first row but in the second column, C lies in the second row and first column, and D lies in the second row and second column. So another definition that we need to know is what we call the order of a matrix. So the order of a matrix is given by stating the number of rows first followed by the number of columns. Not that word, it has to be rows first then followed by column. For example, in this case it means that there are 1 and 2 rows, then 1 and 2 columns. That's why we put here 2 by 2 matrix. So this is what we call a 2 by 2 matrix because it has 2 rows and 2 columns. When you come to this one, you realize that there are 1, 2 and 3. So these are 3 rows, then followed by columns 1, 2. So there are 2 columns. That means that it becomes a 3 by 2 matrix. Then when you go to this one, it will be 1, 2. So those are 2 rows. That's why you put here 2. Then 1, 2, 3. Those are 3 rows, 3 columns. That's why you put here 3. What does that mean? It means that now this one is a 2 by 3 matrix. So that's what we mean by order of a matrix. So next we shall go to addition and subtraction of matrices. So addition and subtraction of matrices involves adding and subtracting corresponding components. Not that word, corresponding components respectively. For example, if I have matrix A which is A, B, C, D and matrix B which is E, F, G, H, it implies that A plus B will be equal to, this is now matrix A and this is now matrix B. Now when I add, I'll come up with this. So how does that come about? Let's see how it comes about. First of all, we have to add, remember we said we add or subtract corresponding components. Now because this is addition, it means that we're all going to add corresponding components. So this one and this are in the same position, first rows, first column. Therefore we shall add both of them to come up with this which is A plus E. Then when we go to the next one, this one and this one in the same position because this is first row second column and this is also first row second column. So when you add the two, we shall come up with this. So we put in the same in the very column first, in this very position which is first row second column. Then for this one, this and this on the same position, so we shall add the two to come up with this. And lastly, this and this are in the same position, so we shall add them to come up with this. So basically that is how they add matrices. What about subtraction? So subtraction still follows the same procedure, only that now this time we don't put add plus sign, we put subtraction sign. For example, this, we shall now say this minus this to come up with this. Then for the next we shall say B plus F to come up with, sorry, B minus F to come up with B minus F. Then next we shall come up with C minus G to come up with that value. And lastly, this d minus h to come up with that value. So basically that's how they add or subtract. So there's something we need to note is that only matrices of the same order can be added or subtracted. For example, if the matrix A is a 3 by 3 matrix, then it implies that matrix B must also be a 3 by 3 matrix. So they have to be of the same order. If this is a 2 by 2, this also has to be a 2 by 2 matrix for you to add or subtract. So that knowledge shall now go to example 1. Example 1 came from UNEB 2009 paper 1 question 7, and it says, given the matrices A, which is 2, 3, 5, 7, find a matrix B such that A plus B, matrix A plus matrix B is equal to 1, 0, 0, 1, and that is for max. So you first come and state what is given. So this is what is given. All that we shall substitute. We know B, so we shall get this. Sorry, we know A, so we shall come and substitute for A to come up with this line. After that, we are going to put this one the other side to come up with B equal to 1, 0, 0, 1 minus 2, 3, 5, 7. Now from there, I'm going to subtract using the same procedure like we have seen in the introduction. I'll say 1 minus 2 to come up with negative 1. Then 0 minus 3 to come up with negative 3. Then 0 minus 5 to come up with negative 5. And lastly 1 minus 7 to come up with negative 6. So basically that's what they wanted, and now let's see how marks can be awarded. So M1 was for substituting for A, then another M1 was for this subtraction, and B1 will be for the first row, another B1 will be for the second row. So they all have to be correct. That's how the 4 marks could be awarded. So now we shall go to example 2, which came from UNEB 1989 paper 1 question 16a, and it says, given the matrices A, which is 2, 1, 3, negative 4, and B, which is 3, 1, 1, 0, and C, which is 1, 0, 2, negative 3, verify that A plus B then plus C is equal to A plus B plus C. So this means that you are going to first add A and B, or that you again add C onto it. This one means you are going to first add B plus C, after that you will add A on it. They want you to verify that they are equal. So what you are going to do in this case, you are going to first add A and B to come up with this. So 2 plus 1 will give you 5, 1 plus 1 will give you 2, 3 plus 1 will give you 4, and negative 4 plus 2 will give you negative 2. Then from there you shall add now 5 to 1 to give you 6, 2 plus 0 to give you 2, 4 plus 2 to give you 6, and negative 2 plus negative 3 to give you negative 5. So that is the first part. Now let's go to this part. So there we are going to first add B plus C. So here we shall come and say 3 plus 1 will give you 4, 1 plus 0 will give you 1, then 1 plus 2 will give you 3, and 2 plus negative 3 will give you negative 1. Then from there we shall now add the 2 to come up with 2 plus 4 to come up with 6, 1 plus 1 2, 3 plus 1 3, 6, and negative 4 plus negative 1 to give you negative 5. So I think we realize that they are equal. So this is the same matrix as this, meaning that those two are equal. So we shall come and conclude that this is equal to this, which is equal to that as required. So basically we have verified what they wanted, and now let's see how marks can be awarded. So M1 will be for substitution here, for substituting A, B, and C. Then M1 will be for this addition, and A1 for the output. Then your M1 is for this addition, and A1 is for the output, and B1 is for conclusion. So basically that's how the marks could be awarded. So now before we go to the next example, we have to see something called multiplication of a matrix by a scalar. So a scalar is like a constant value. It can be an integer, it can be a fraction, as long as it's just a value. So when a matrix is multiplied by a scalar, each value in the matrix is multiplied by the given scalar. E.g., if A is equal, matrix A is A, B, C, D, then it implies that K times A, so this K is a scalar, it's a value, an integer or a fraction, multiplied by a matrix A will come up with this to come up. And after that, we shall remember that the rules say that this matrix is, each value in the matrix is multiplied by the given scalar. So A will be multiplied by K to come up with this, then K still with B to come up with that, then K still with C to come up with this, and D still with K still with K with D to come up with KD. So basically that's how a scalar and a matrix can be multiplied. Now with that knowledge, I'll go to example 3, which came to from UNEB 2013 paper 1 question 7, and it says, if matrix A is 2, 3, 4, 2 and matrix B is 6, negative 2, 7, 3, calculate 2A minus B. I think we realize that now matrix A is going to be multiplied by a scalar. So we shall come and say that 2A minus B is equal to 2, so this A will be substituted and this B will be substituted. Now the first thing to do is to multiply this scalar throughout matrix A. So when you do that, you shall come up with that. I think we realize that 2 times 2 to give you 4, then still 2 times 3 to give you 6, 2 times 4 to give you 8, and 2 times 2 to give you 4. Now after getting this 2A, we can now subtract B to come up with that. So 4 minus 6 to give you negative 2, 6 minus negative 2 to give you 8, and then for this row 8 minus 7 to come up with 1, and 4 minus 3 to come up with 1. So basically that's what they wanted, and now let's see how marks can be awarded. So M1 is for substitution, and another M1 is for this scalar multiplication and subtraction, then A1 is for the output. So basically that's how the marks could be awarded. So that brings us to the end of this video. Thank you for watching, and be reminded that the next video will be on multiplication of 2 matrices. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video on multiplication of 2 matrices has been uploaded. Otherwise, thank you for watching, and also if you know of any student who is not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp so that we can all benefit as a family.